In this session we will cover the topic related to circle and its properties.
Hello and welcome to this session. So today we are going to cover circle and the circle properties. What is circle? Circle is the set of point which is always equidistant from the fixed point, and the fixed point is nothing but the center. Okay, so center of a circle, okay, from the fixed point to all the point which are equidistant. If I will try to draw a line, this line is nothing but, or the distance between these 2 points is known as radius. Okay, so radius is the distance from the center to the circumference of a circle. Okay, now this whole length, right, this whole length is known as circumference. Okay, or the perimeter, we can say circumference of a circle. So circumference is nothing but 2 into pi into r, where r is a radius. Okay, now there is a, if you see, this is one line which is dividing the circle in two parts. This line is nothing but the chord. So chord is a line which divides the circle in two parts. Okay, now if you'll see a chord which is passing through the center, it is dividing into two equal parts, right? So that chord or the longest chord is known as diameter. Okay, so diameter is nothing but it is the longest chord which divides the circle in two equal parts, and this is the 2 times of the radius. So if you'll see, r plus r, which is going to be the diameter. So d is equals to 2r. It is the relation between the diameter and the radius. Now tangent. Tangent is a line which touches the circle at a single point. If I'll draw a line like this one, if you'll see, at this point it is touching, right? So it touches the circle at a single point. So we can say this is nothing but tangent. Okay, so tangent is a line which touches the circle at a single point. Okay, now secant. Secant is a line, it's an extension of the chord, but like this. That means it is what, intersecting at 2 points. So when it intersects at 2 points, we call it a secant. Okay, so secant is nothing but it is an extension of a chord, but it intersects at 2 points. Instead of touching, like if you see, it is inside the circle, it is what, outside. It is intersecting at this point and this point, so we call it a secant. Okay, now coming to the circle properties, equal chord and the perpendicular bisector. Okay, so if suppose if I am going to draw a circle, consider this is a circle. Okay, if I draw a chord, okay, so any line which is drawn from chord to the circle, if you'll see this one, right, so this line is perpendicular. If this line is perpendicular, then it bisects the chord in two equal parts. Okay, also if the circle is like, consider this is a circle, I'm considering this circle. Okay, now one chord is this one, and just take another chord is this one. If chords are equal, right, okay, say if chords are equal, then the distance is also same from the center. Okay, so equal chord and the perpendicular bisector, if these are the perpendicular bisector, then it will divide into the two equal part. It will divide into the two equal part. This we call it radius, this we call it a radius. Okay, in this scenario we can take this as a radius and this as a radius. If you'll see here, these two triangles are congruent, right? So if those two triangles are congruent, that means each part, like this angle is equals to this angle is going to be equals to this angle, and this angle is going to be equal. So this is one. The chord, if a line drawn perpendicular from chord from center of the circle to the chord, it will bisect the chord. Okay, or in other way we can say, if a line which is bisecting the chord, then it will be perpendicular to the chord. Okay, now next, if you'll see here, tangent we already discussed, right? Tangent is the line which touches the circle at a single point. Now any tangent which is drawn from external point, right? How many triangles we can draw? 2 triangles. Maximum we can draw 2 triangles if you see. And this tangent, length of the tangent is always going to be same. That means AC is equals to BC. Okay, so in this scenario, if you'll see AC and BC is equals to be same. OB and OA is radius, so I am going to write here radius R. Okay, this and this is going to be same, so I am going, if it is X, then this is also going to be X, right? And this is what a common, right? If you'll see, this is what common. So both the triangles are congruent. If both the triangles are congruent using RHS, right angle, RHS is like right angle, hypotenuse and one side. A right angle is there, if you'll see, hypotenuse is OC and one side is like OB and OA, we can consider, right? So in this scenario, both the triangles are congruent. If both the triangles are congruent, in that scenario, each and every part will be equal. That means this going to be equals to this, right? This angle is going to be this one. Okay, so if you'll see, we'll use the same property over here. This is 20, so I'm going to write here this is going to be 20. If this is X, I'm going to write here X. Now this is what radius and tangent is always going to be 90 degree. So this is going to be 90, 90, 20 and X. This is a right angle triangle, right? So we can write here X plus 90 plus 20 is equals to 180. X is going to be 180 minus 110. X is equals to 70 degree. So like this way, we can identify the value of X. Angle in a semicircle is always going to be 90 degree. If you see, this is a AB is a what chord, which is the longest chord, which is dividing into the two parts. So this is what AB, this part is semicircle. So angle, any angle if you draw, it is always going to be 90 degree. Angle in a semicircle is always going to be 90 degree. So this is 90, this is going to be 90, C1 and C2 is going to be same. So let's solve this question. If you see the first question, this is going to be what? I am writing here this is 90 degree because angle in a semicircle. Now this angle we know 90 plus 45, so this angle we can suppose Y. So 45 plus 90 plus Y is going to be 180. Y is equals to 180 minus 90 plus 45, 135. Subtract it, 80 minus 5. So this is 5. 7 minus 3 is 5, 55. Okay, 45. Okay, so 45, my bad. So 45, so this angle is 45. So I can write here this is 45. So X we have to identify. X is equals to 180 minus 45. Why? Because this is a linear pair, straight line. So I can write here X is equals to 135. Or we can use directly property. This is what external angle, this is what opposite to external angle, right? External angle is equals to the sum of the interior opposite angle. That means 90 plus 45, which is going to be 135. Okay, similarly here it is going to be 90. So this is going to be 20, right? Because 110, so this is going to be 70. 90, 70 and 20. Like this way we can write. Angle between the tangent and the radius of the circle. So angle between the tangent is always going to be 90. Okay, tangent is always going to be perpendicular to the radius. That means this is 90 degree. Okay, let's solve this one. This is going to be 90 degree. This is going to be 90 degree. And this is what X. So this is what a quadrilateral. X plus 90 plus 140 plus 90 is going to be 360. X is going to be 360 minus 180 minus 140. Right, 90, 90, 180 and minus 140. 180 minus 40, which is going to be 40, or we can directly write angle at the center of a circle. So angle in this, if the angle subtended at the center of a circle by an arc, this is one arc which is subtending angle at the center, is always twice the size of the angle on the circumference subtended by the same arc. So if it is going to be X, then this is going to be 2X. If it is going to be 2X, then this is going to be X. Okay, so this is our angle at the center property. So in this case, if you'll see O this is going to be 40. I'm going to write why 40 because this is our radius, this is our radius, this is an isosceles triangle. So this angle we can find out. Why? Because angle some property, right? So 40, 40, and this is going to be 100. So angle, I'm writing as z. So z is going to be 100. Now angle at the center by this arc, if you'll see, it is making angle z, which is 100. So x is going to be half of this, is which is going to be 50. Okay, now we know x. Now this is what, if you see this and this is equal, that means this angle and this angle is going to be equal. So I am going to write here x, this is going to be x, y plus 40, y plus 40, again y plus 40 because these two angle will be equal, right? If it is 40, 40, this is y, so this is also going to be y. So y plus 40 is equals to 180 degree. So in this scenario, I can write here x 2 times of y plus 40 is equals to 180. X we know, right? 50. Substitute it. 2y plus 40 is going to be 180 minus 50. Y plus 40 is going to be 130 divided by 2, which is 65. So y is equals to 25. So like this way we can find out the value of y. Angle in the same segment. So angle in the same segment are always equal. So if you see, this is one arc which is making angle x, and again this is also making angle x. So those are equal. Similarly here, if 33, this is what making 33 with the help of this arc, right? So this is b also going to be 33. So like this way we can use this property to identify the value of angle in the same arc. Okay, now if you'll see this angle, how we can find this angle, and this angle is going to be equal. Why? Because this is what opposite angles, right? So if it is x, then this is going to be x, right? And again, if I'll use this property, angle in the same segment, right? X, then this is, suppose y, so y, so this is going to be y and y, right? So angle sum, using this property we can identify the value of missing. Okay, so like this way we can find. Now if you see cyclic quadrilateral, what is cyclic quadrilateral? If all the point of a quadrilateral, if you see P, Q, R, S, all the vertices of a quadrilateral are lying on the circumference of a circle or on the circle, we can say cyclic quadrilateral. So what is property of a cyclic quadrilateral? First property, simple quadrilateral, if it is there, then sum of all the angle is going to be 360. P, Q, R plus S is equals to 360 degree. Another property of the cyclic quadrilateral is opposite angle. Sum of the opposite angle is going to be supplementary. That means P plus angle R is going to be 180. Angle S plus angle Q is going to be 180. So simple case, this is also an example of cyclic quadrilateral. A plus 100 is 180. So A is going to be 80 degree and B is going to 180 minus 115. Subtract it, 65. So like this way we can identify. So this is all about this circle and the properties of a circle. I will also come with another videos where from the past paper questions. Please share and subscribe. Thank you for watching.